In the last few videos, we've been doing a whole lot of coding math. Now, coding math's really great for practice and other things, but one thing that I don't really like about it is that the problems are a bit contrived. And what I mean by that is that all of those problems that we've been doing don't really have a point. They're kind of just made for the sake of you doing a problem to practice some booleans, which for the last two videos has been really useful, but let's actually do a few programs that will use the same sort of Boolean logic, but feel a little bit more real. Let's start up here in this video. We're going to tackle this leap year program. So what is the point of this program? Is it's going to tell us if a given year is a leap year or not. Now, you might not have known this, but there's actually some interesting rules to leap years. First of all, why is a year a leap year? Because it doesn't actually take 365 days for us to go around the sun. It actually takes more like 365.25. That's why there's a leap year every 4 years. But it's a little more complicated than that. Really, it's 365.2487 days that it takes. So here are the rules of leap years. If you're divisible by 4, if you're a year divisible by 4, then you're a leap year. Unless you're divisible by 100, in which case you're not. So 2100 will actually not be a leap year. There's a third rule, which is that if you are divisible by 400, you actually are a leap year. So the year 2000 actually was a leap year. So 2096, there will be a leap year, and 2100 will not be a leap year. 1999 was not a leap year, but 2000 was. Before we had this conversation, probably your first thought was we can just check if the year is divisible by 4, but now it's a little more complicated than that. So let's do this. Let's do int year equals read int and enter a year. Then let's do if is leap year here. Let's print line it's a leap year. Else let's print line not a leap year. Now we're going to write this method called isLeapYear. So let's do public. What type should this return? Well, it's in the parentheses of an if statement, so it should probably return a Boolean isLeapYear, which takes in a year as a parameter. So again, before you might have thought that we can just do if year, remember how we check divisibility is with mod, so I can do mod 4 equals 0. I could return true, else return false. But now we actually know that the rules are a little more complicated than this. So let's do this. Out of all of those, when do I know for a fact that it's a leap year? If we're divisible by 400. So let's do this. If year mod 400 is 0, it is a leap year. Else if, when is the other case when I'm a leap year? When I'm divisible by 4 and also not divisible by 100. So let's do if year mod 4 equals 0 and year mod 100. Remember, I can do bang equals, which means does not equal 0. Then I can return true. Else I can return false. And we've seen this before. Can I actually Boolean Zen this? Heck yeah, I can. Let's take this. I'm returning the same thing in here, which means I'm going to return true if that's true, or if this is true, which means I can combine these with an or. And now, do you see any of the patterns of our rules of Boolean Zen? I actually see this last one here. If something, return true, else return false. So I can actually just return all of this. And if we compile this and run it, you should see that it can correctly figure out which years are leap years. So if I run this and I do, let's say, 2100 is not a leap year. But if I do, I don't know, 2004 was a leap year. Let's do 1999, not a leap year. And then let's try the year 2000 actually was a leap year. So there we go. Again, maybe not the most useful example, but something that feels a little bit more real than squirrels at a cigar party. So our first kind of real life Boolean example.